Hello, good morning, class. Uh, Good morning, students of Mayo. Today we will be discussing about input and output functions of Arduino Uno, um, as well as a small demonstration of how this works in real life in comparison to what we are currently using in what is called as TinkerCAD. I'm already aware that most of us don't really have complete Arduino kits. This is especially prevalent for non-STEM students as they are not being required to have actually have their own Arduino kits. So today, I will be showing you uh, how the thing works and how we create the program itself in order to make it function according to what we actually intended to do. So you can see in our bottom left of our screen, there is currently a camera feed in which it is currently showing us uh, an actual Arduino Uno just beside me, as you can see, um, with a blinking LED bulb. We will also be simulating the same here in our browser using TinkerCAD in order to demonstrate the differences and the comparison between uh, both of the simulations. So, as today it will be it is as today our lesson is regarding input and output. I will be orienting you about how input and output really works in Arduino. So let me just rotate this Arduino Uno for a bit so it will be a bit visible for you. Drag this up, zoom this in. So when we say Arduino input output, we are referring to how Arduino controls things, which is output, and how the Arduino is able to take in information as some sort of sense, right? Arduino Uno is meant to simulate how uh, living beings are able to sense things through sight, to smell, through touch. It is trying to simulate things like that in order to automate some of the functionalities that we are experiencing in our digital world. So, we will be starting with input. Most of this in the right side of our Arduino Uno are input pins. So, you will notice there are pins labeled as digital pins. So, pin uh, 0 to 13. Pin 0 to 13 are what we consider digital pins. So, digital pins uh, actually is governed by how uh, electricity works or electronics work for most of these microcontroller devices, which is on and off. So most of electronic devices only know binary as their computer language, right? So this is the same here for the digital pins. There is only two states of output, uh, on or off, 1 or 0, high or low. There are some minor differences though. If you notice, there are pins marked with tilde, which is pin 3, pin 5, pin 9, pin 10, and pin 11. They are what we call pulse width modulation pins. Pulse width modulation or PWM are pins in which they are capable of simulating uh, analog. They're capable of simulating analog. So these pins are actually interchangeable with input and output, no? These digital pins are actually interchangeable with input and output. Now we go to the left side of our screen. We have what we call analog. So most of these analog pins are input, but instead of actually receiving digital inputs which is dictated by either on or off, high or low, analog pins are capable of finer tuning, precise tuning. For example, there are data that cannot be received by either 1 or 0, right? Like 1.5, 1.75, 1.25, -1. So analog pins are able to receive such. As you will notice, it is indicated by the word analog in. It means it is capable of taking in analog input. So what kind of inputs are analog inputs? So let me just show you some of the electronic devices that are to be considered as analog input. Let's see here. So this one, I think you can see this in the screen, is a joystick that you can use with actually with your Arduino. So simpler buttons such as up and down, left or right are digital inputs because they are only governed by actually four cardinal directions, right? But for this one, there is actually finer tuning here in which it cannot be actually dictated easily by left or right, up and down. So this is a kind of analog input. So I think you're already getting the gist of what I mean, no? Next one is RFID. So this kind of things are similar to what we have in our ATMs, credit cards, as well as uh, SIM cards. So RFID technology is actually in our phones, in almost in our everyday life. Another more common example that is actually built in into our phones are GPS. So GPS is a kind of uh, chip that sends analog signals about the precise position of a person in our world, triangulated by three simultaneous images of satellites revolving all around our Earth. So now we will be proceeding to why we are currently having our uh, demonstration here. So as you will notice, there is currently a blinking light here. So you will also see the code that actually is being used to implement such. So I will be explaining the code, but first let me simulate this in TinkerCAD. So let's go back to TinkerCAD and recreate this, the one that I have just made. So here. So as you will notice, there are extra wires here. So I will just be adding the extra wires there so that you will see the okay. Let's label this red. Then ground. Let's label this black. If I zoom into to our demonstration, let me zoom this in. So as you are going to notice, this is a similar pin out. I'm just copying everything. If you look at our Arduino, there are currently multiple ground pins that you can actually use. So these ground pins, which is actually a negative polarity, can be interchangeable. So you can either use one of the three ground pins that you can find in the Arduino Uno. So you may use this, you may use the two of the ground pins here, it would be the same. So a ground pin is provided here for convenience sake only. Then we have inserted a LED bulb. Let's put this here. Then a resistor. Resistor. Okay. Particular. Let me just move this a bit here. Particular at 220 ohm resistor. I'm using 220 ohm resistor here. Then you will see that there is a wire, a yellow wire that is running from pin 8. Or rather yellow, it is an orange wire. Okay, let's just color this orange so that we actually follow everything that I have done so far. So now, let's try starting the simulation. Sir, it is not currently running. Are you perhaps reversing something in your simulation? Perhaps, so let's check if it actually is reversed. So let's try this one. Okay. Start the simulation again. Sir, there is no light. Are you sure about this? So, okay. Let's go back here. Let's check at our code. So, you will notice there are several blocks of code here, but there is no actual demonstration of how it actually looks like. So, if we look at our left side of our screen, this is what we call Arduino IDE. So in this platform, you are able to code what you are going to be simulating on your program. So let's try text. Okay. So now we are presented with a code that is similar to the one that we is currently doing in our in live demonstration. So coding, before we start coding in our TinkerCAD, I will be explaining you the code that is currently running in our Arduino Studio. We declared an integer and name it LED. So again, let me label this. We declared an integer named LED and assigned a value of 8. So what we're doing here is that um, we are assigning the value of um, lead. We named our integer named lead and assign it a value of 8. So now we have a variable named lead that has a value of 8. Actually, the name lead is actually interchangeable. So the variables you might be familiar with are x, y, z, a, b, c. So let's just switch it up like to the familiar ones that you're actually accustomed to. So let's just type x. Then change every word here that has led to x. Okay. Now, uh, we are invoking the function called pin mode. So pin mode is a function built in into our Arduino program. We're actually calling the pins here. So for pin mode, we're actually first doing this in setup. So this function here allows us to use the pin uh, for future use. So basically, we are calling the pin in advance for us to use it in the future. So now the number 8 is being invoked here because we are going to replace the variable with the actual value, right? So let me just make the screen a bit bigger. Did it get bigger on your screen? Wait, let me just readjust this so just to make sure that actually became bigger on your screen. Okay. So now we are trying to change its input, or rather we are changing it that we are going to display as it as output. So we can either use it as input or output. So for this instance, we are using it as output, meaning it is trying to send signals out of the Arduino Uno. In loop, you will notice here that there is a digital write. There are some various codes here. So there is actually a label here. So digital write X, which is pin 8, then we assigned it a value of high. High meaning on or 1. When we say high here in digital write, we are meaning on. So take into your mind that we are actually referring high as on and low as off. So digital write pin 8 is high, then delay here, which is usually measured in milliseconds. So meaning we are actually delaying it for 500 milliseconds, which is half a second, then turning it off. So what is currently happening here? Let me zoom out the phone a bit, as you cannot see the. Okay. So because of this code, you will see that it is blinking at a rate of 500 milliseconds. So let's switch up the code a bit. Sir, what will happen if this line of code here is put in setup? So let's just try that out. What will happen, sir, if the code is in setup? So let's try running it. To run it in our Arduino, we will be pressing upload, meaning we are transferring our code from our computer to the Arduino. Let's try running this. So it is shutting down. So you will notice it only blinks for a single time. Again, void setup only makes the program or any code found within its borders run once and only during the turning on of our Arduino Uno. So every time we press upload, it will just run the code once. So that is the function of setup. So if you have uh, intentionally, if you have a code that intentionally runs once in the life cycle of the program, then it should be in void setup. Now, we will be returning this back to void loop. So it will be returning to its normal processes or normal process of blinking on and off. Okay. Now, we will be doing the same here in TinkerCAD. So, we will be repeating our code. So, int x is equals to 8, or assign the value of 8 rather, then pin mode x, then uh, x high, then the delay should be 500. We can remove the comment. Then again, we will be replacing this with x. Then another 500. So let's try simulating our code. So it should be pretty similar with what we have here on our left side. Sir, I'm not seeing anything. It's not turning on. So let's check our bulb if we actually oriented it correctly. So let's try adjusting the bulb, then running it again. Sir, it's not turning on. I'm not seeing any improvement in the code. So let's try diagnosing our program for a bit. So let's zoom this out. So ground should be on the negative side, right? So as you can see here, black is not actually uh, well grounded here. So let's just readjust it back here. Okay. Then color black. Let's check if it actually has a flow of electricity here. So let's try this again. Then put a wire here, then directly to the other side. So pin 8. So this should make this turn on if for some reason I don't know why it is not turning on, but it should be turning on because the code is similar as well as the pinouts are similar. So now we will be going to our explanations here. So pins configured as input. As we have already discussed, you must first declare pin mode. For pull-up resistors, usually pull-up resistors are what we call uh, the button switches. So pull-up resistors usually pro output resistance every time a button is pressed. So there we have two types. We have pull up and pull down resistor. So for output, um, usually it is also used in conjunction with what we call pull-up resistors. So unfortunately, we don't have any pull-up resistors at the moment, so we will not be able to um, demonstrate it. So I will just be showing you some of the code. So now we will be trying, I will be trying to demonstrate to you how RGB LED work. So let me show you an actual RGB LED. I'm sure you have already seen one in your uh seen one. Let me just so this is an actual RGB LED. I will be showing it in the screen here. So this is an RGB LED. Let me just focus this. So this is an RGB LED. So RGB LED actually features three bulbs or three colors inside a single bulb. So let me focus this back at our Arduino Uno. So let's clear the code out first so that we avoid any errors. So to clear the code in our Arduino Studio, we simply remove the current code in our Arduino. So we will be erasing this. Okay. Then upload it. So now you will notice the bulb isn't turning on anymore. It is because um, we are not actually sending any signals anymore from pin 8. So now we will be first identifying which of these pins actually has each of these functions. So we will be searching Google and search for an RGB pin out, RGB LED pin out. So now that we have an RGB pen or RGB LED pin out, we should be able to identify now which is which. So following with the instruction, the leftmost side should be red. So let's start inserting. Let me zoom this in first before we start. Okay, okay, there. So now I will be inserting each of the pins so that they will have their own. Uh, let's try removing this. Also, each of the headers, we will call this pin's headers. Each of the headers should have its own resistors. So we need three sets of resistors for each color. One for the red, one for the green, and one for blue. We could also avoid using multiple resistors by actually applying the resistance in the positive side. So let's just try this one. So I am inserting red at pin 1. Okay, there. So let me just fix the camera a bit. Okay. Now we have inserted the RGB LED. Wait, let me orient. Okay, there. Then we will be needing a set of three resistors for this project. So let me look for a resistor to use. Or rather, we will be using a single resistor in which we will be using it in our negative lane. So now, let me remove the wires here. First, we are going to assign this black pin to the ground. So let's put this in ground. Then insert it directly to our pin, which is the ground should be found in pin 2. Okay. But first, we are going to apply a resistor here. Okay. Okay. Now, we're going to apply different pins for each of the colors. So, I should have enough wires for each of the color. Let me check. So, this is the red. Pin 1 is red. I'll be assigning it number. Let's just assign it to number 8. Then, green should be in pin 3. So, I will be assigning it to pin 7. Then, another wire in which we will be putting it for blue, which is in pin 4. So, I will be assigning this to pin 4. 6, 5, 4. Okay. Now that we have pins for our LED here. Okay, let me orient this. Okay. So, first we are going to recreate the circuit here. So, let me remove the wires. So, I have inserted an RGB LED. So, let's move this code for a bit. RGB LED. So, let's look for if they have a LED. Okay. They have an RGB LED here. So, what I did is I put the RGB LED like this. As you can see here, I will be zooming this in. Okay. Wait, I'm having trouble orienting. So, okay. Let me zoom this out. Okay, there. So, I have inserted a resistor. Inserted a resistor in our negative, in our ground. Resistor, which is 220 ohms. Then inserted it here. Okay. Then, uh, Red should be at pin 8. So let's put red for pin 8. Oops, I did the pin wrong. Let me remove this. Red should be pin 8. Then uh, green should be pin 7. And blue should be pin 4. Let's color this blue. Then lastly, ground. Let's color this black. Now, we will be making up the code for our um, for this to function. So let's start with the variables. Again, we are going to declare the variables. Instead of naming it X, Y, or Z, we will be naming it according to the color. So let's just say red. Again, we have put red in 8. Then in green is in pin 7. And lastly, blue is in pin 4. So we will be turning on the pins for future use here. So pin mode, then red, then output. Then we can just pretty much copy paste this 2 more times for green and blue. Then now we are going to be putting this below for the high and low. So let's put this here. Then we will make them turn on or off. So high, then low. Then let's put a delay a bit. Delay. Let's assign the delay at about maybe 500 milliseconds. Then uh, we'll put the low to allow it to blink. If we did this correctly, this should be turning on and off unless we have reversed the pins in which we will immediately blow out the uh, LED bulb. But you do not have to worry about blowing out such LED bulbs. Actually, um, such LED bulbs are easily be purchased in most electronic stores. They are very cheap. So now that we have created our uh, blinker for our RGB LED, because we are mixing both red, green, and blue, the output should be white. Red plus green plus blue is white. So this should be blinking white if we did this correctly. So let's try it out. So let's wait for a bit. So the bulb is not actually turning on. Maybe we have a problem. So we will be trying this code out uh in our simulation. So now we will just be pasting this code. You can simply paste this code here. Okay. So let's try if it actually turns on. So perhaps uh we have a mistake here in our program, but I don't think we actually have something wrong in our program. No, maybe we actually lack the resistors that we are needing for this program to run. So let's try wiping out the code first. Let's try wiping out the code first. Then try adding more resistors to this. So let me get some resistors that we can use. Guys, if you have any questions, kindly interrupt my class right now. You can ask your questions right away. So everything should be correct here, except that instead of three or one resistor here, each of this wiring should have their own resistor. Let's try moving this upward. Let me try stopping the simulation and moving our LED upwards. So this one should be tripled instead. Then let's copy this and create another one and one more. So this should be the correctly done simulation, or rather uh, our program. This should be how it is done accurately. So let me just run this before we conclude our class for today. Okay, ground, then black. So this should be how it should function. Sige. Any questions before we conclude our class for today? Any questions regarding our discussions?
So far, so
Okay. I think
So,
that
mhm.
yes.
Hindi po sa discussion pero about po sa exam, ano po yung performance exam na gagawin namin?
Wait.